All right, let's finish up section 5.3. And so we looked at some special values that show up on what's called the unit circle, which we'll talk about in class tomorrow. But I also want to get into in this section a few different identities. So these identities are going to come up several times during this unit and the next unit. So you're going to want to be really familiar with these. And basically what an identity is, it's sort of like it's an equation where it gives you two different things that are equivalent. So we're looking at the 6 trig functions that we talked about earlier. So earlier in the notes, we talked about the 6 trig ratios, the sine, cosine, tangent, and then the reciprocal functions, secant, cosecant, and cotangent. And so what these identities do is they give us a way to relate all of these different trig ratios in different contexts. So let's start with the reciprocal identities. So this one at the top of the chart there, these functions, my pen to work here, these functions that are here are all reciprocals of the ones that are below them. All right, so, sorry, I'm having trouble with my pen. Okay, here we go. I think I got it working now. So the sine function is the reciprocal of the cosecant function. So sine is the reciprocal of 1 over cosecant. So sine of theta, if I needed to compute it using cosecant, I could always say it's 1 over cosecant theta. And likewise, cosecant theta is 1 over the sine function, so 1 over sine theta. Cosine is the reciprocal of the secant function, so cosine can be expressed as 1 over secant theta. And then likewise, secant theta can be expressed as 1 over cosine theta. All right, let's see if I can get rid of all these weird pen marks. Had my tablet turned the wrong way, so I think we're good now. All right, and then tangent is the reciprocal of cotangent. So tangent is equal to, can be written as 1 over the cotangent should we need that. And then likewise, cotangent can be written as 1 over tangent of theta. All right, and then we've got two what we call quotient identities, and these are very useful. I go back to these all the time because what they do is they give me a relationship between tangent and cotangent and the sine and cosine functions. Sine and cosine are the most, most common, to me the most useful. They're used more than anything else. Everything goes back to sine and cosine at the end of the day. And so if I can ever get something that gets me back to sine and cosine, that's going to make things easier down the road. So the first one, the tangent theta, can also be expressed as the ratio of the sine function over the cosine function. So tangent theta is equal to sine theta over cosine theta. And then because cotangent is the reciprocal of tangent, remember what reciprocal means, that's where you take a fraction and you flip the numerator and denominator. Cotangent then can also be expressed as the cosine theta over the sine theta, okay? So you see that these are reciprocals of each other as we would expect. So if tangent is sine over cosine, cotangent can be expressed as cosine over sine. Okay, then we've got 3 what we call Pythagorean identities. The first one's probably the most fundamental that comes up the most often, and that would be the cosine squared theta plus sine squared theta equals 1. And this actually does come from the Pythagorean theorem. I'll show you in class where we get it from using a right triangle, but for now you can just take my word for it. Cosine squared theta plus sine squared theta, doesn't matter what theta is, that expression will always simplify to 1. Okay, and then let's see, we've got 1 plus tangent squared theta, that's the next one, equals secant squared theta. Make sure I've got that right. At least I'm doing it from memory. So if we divide, yeah. So 1 plus tangent squared theta equals secant squared theta is another one that comes up from time to time. It's not quite as common as the first one. This is the one we'll use most often, but this one comes up from time to time. And then there's another one that says 1 plus cotangent squared theta is equal to cosecant squared theta. Yeah, so yeah. All right, those are the 3 that we're going to use from time to time. So 1 plus cotangent squared theta equals cosecant squared theta, and 1 plus tangent squared theta equals secant squared theta. All right. There's a couple of others. So even and odd functions we didn't get too much into even and odd functions this semester, but a couple of things to remember: that sine is an odd function, considered an odd function, and cosine is considered an even function. Quick refresher, the definition, and again, we didn't get into this earlier in the semester because we were a little short on time, but let me just remind you of what this is from high school algebra. If a function is even, the definition of an even function is that f of negative x should just simplify to f of x. So with that in mind, if I tell you that cosine is an even function, then we can say cosine of negative theta is always going to just simplify to cosine of theta. And then definition of an odd function is that f of negative x should simplify to negative f of x. And so if I tell you that, if that's the definition of an odd function, and I tell you that sine is an odd function, that means sine of negative theta should simplify to negative sine of theta. And then likewise, tangent is an odd function as well. So that means that tangent of negative theta, based on this definition, tangent of negative theta would simplify to negative tangent of theta. And then let's see, cosine, the reciprocal of cosine, remember earlier, we said the reciprocal of cosine was the secant function back here. So if cosine is an even function, the secant function will also be even. So that means that the secant function, secant of negative theta, would simplify to, because it's even, using this definition, secant of theta. And then the reciprocal of sine, the sine function, the reciprocal was cosecant. And so that means that cosecant would be an odd function, just like sine was. So cosecant of negative theta would simplify to negative cosecant theta. And then likewise, cotangent is also an odd function. So cotangent of negative theta would simplify to negative cotangent of theta. I'm not sure how often these are going to come up, but from time to time, they might help us solve some problems. So I want to have them in your notes. All right, so example 5, it says, given that sine of t is equal to 2/5 and cosine of t equals the square root of 21 over 5, use the identities above to find the values of each of the 4 remaining trig functions. Now, I want you to notice, we don't know what t is. T is the angle, so you always have to have sine of an angle or cosine of an angle, right? That angle has to be in there, whether you call it t or theta or x, it doesn't really matter. I don't know what the angle is, but I do know the sine of the angle is 2/5, and I know the cosine of the angle is the square root of 21 over 5. So what they're asking me to do is find the other 4, tangent of t, cotangent of t, secant of t, and cosecant of t. So the order we do these in doesn't really make a difference. I would say let's start with tangent. And so remember earlier I said that tangent always goes back to sine and cosine, and it does based on this quotient identity right here. Tangent is equal to sine over cosine. So tangent of t can be found by writing the sine of t over the cosine of t. And so if I take these two expressions and I just make that ratio, I'm going to have 2 over 5 over the square root of 21 over 5. And then if you have a complex fraction like this, I want you to go ahead and simplify it. You're going to multiply by the reciprocal of the denominator, so 5 over the square root of 21. These will cross out, and so I've got 2 over the square root of 21. If you check the answer in the back of the book, they're going to tell you to rationalize the denominator. I'm going to leave this for now unrationalized. I'm not terribly concerned with that. I want to make sure you focus on the fact that tangent was found by taking the sine ratio and dividing the sine expression and dividing it by the cosine expression. All right, so then the other trig functions, let's do, it doesn't matter the order we do them in, let's do cosecant next. So recall from earlier, cosecant was the reciprocal of the sine function right here. So there's a couple ways we could do this. One way we could do this is to say, okay, cosecant is literally 1 over the sine function. But if you think about what a reciprocal is, a reciprocal, like I said earlier, it's really where you take a fraction and you just flip it. So if I know that cosecant is the reciprocal of sine, here I'll make a quick note, that's the reciprocal of the sine function, okay, then I can just take the sine function and literally flip it. So if sine was 2/5, the cosecant reciprocal is going to be 5 over 2. So the cosecant function is 5 over 2. Secant is the reciprocal of the cosine function. So cosine is the reciprocal of secant. So again, just using the fact that that's the reciprocal, take the cosine function. So here we'll make a quick note. This is the reciprocal of the cosine function. I'm going to take the cosine function. I'm going to flip it. So I have 5 over the square root of 21. And again, I'm going to leave this unrationalized for now. I'm just going to leave the radical in the denominator and not worry about it. All right, so then finally the last one is cotangent of t. There's a couple ways we could do this. One way we could do this is to go back up here and use this quotient identity and say that cotangent is cosine over sine. The other way to do this is because we already know what tangent is. We figured that out earlier. Tangent is the reciprocal of cotangent. These are reciprocal functions. So since I've already found the tangent value, I can just find the cotangent by doing the reciprocal of that. So we can do that. Let's do that. Reciprocal of the tangent function. And so if tangent was 2 over the square root of 21, cotangent is going to be the square root of 21 over 2. All right, so these are my other 4 trig functions right here. For this particular angle t, whatever it is, we don't know. We don't care what t is. We just needed to know what the other 4 trig ratios were for that particular location. Okay, number 6, it says given that sine of t equals 3/5, and they tell you that it's in the first quadrant. So how did I get that? Because they told me that t was between 0 and pi over 2. And remember in the previous video, I know we did it somewhere up here, we talked about labeling the unit circle. And remember we said that 0 was on the positive x-axis. Pi over 2 was up here where the positive y-axis would have been. Let me see if I have another picture of it here. This is kind of messy. Let me draw a picture down here so you see what I'm talking about. So a lot of times what they'll do on a question like this is they'll give you the quadrant based on these radian measures. So here's what I mean. If it says t is between 0 to pi over 2, so here's the way your circle's labeled. So don't forget this. We've got 0, this would be a half pi. Remember, this would be a whole pi. This down here would be 3 halves pi, right? And then when you repeat, it's 2 pi. Remember, we can go around the circle as many times as we need to. So if I'm at 0 to pi over 2 is where they're telling me, that means that I'm right here. I'm in this first quadrant. So we're in quadrant 1, okay? So it says, given that sine of t equals 3/5, find cosine of t using a trigonometric identity. A couple ways we could do this. They said to use a trig identity. So I would go ahead, because I know sine and they're asking me for cosine, I would use the trig identity that relates just sine and cosine. So that would be the Pythagorean identity right here. Cosine squared theta plus sine squared theta equals 1. So let's write that down. So cosine squared theta, I'm going to use t because I use t. Cosine squared t plus sine squared t equals 1. All right, so sine is 3 over 5. So I'm going to replace the sine expression with 3 over 5. And make sure you see what's going on. Sine, by the way, let's talk a little bit about notation for a minute. When you see something like this, sine squared of t, what that really means is that you're taking the entire trig ratio and you're squaring it, okay? So when you see a power, shorthand, we write it this way, but this is really what we mean. We're taking whatever that sine ratio is and we're squaring it. That's what that notation means. So if sine of t is 3 over 5, sine squared will be 3 over 5 squared. So I'm literally replacing the sine expression with 3 over 5, and I'm going to square it because of the identity. So what we need to do is we need to solve this equation for cosine. So I'm going to go ahead and square it first. So that gives me 9 over 25. And then I need to get cosine by itself. So that means I'm going to subtract the 9 over 25. And I need to get a common denominator. This would be 25 over 25. So that means I've got cosine squared t equals 25 take away 9 gives me 16 over 25. So then I'm going to take the square root. Now, the thing to remember when you take a square root, you've got to remember plus minus. Remember that? So the square root of 16 is 4. The square root of 25 is 5. Normally we would do plus minus. Don't forget the plus minus. However, because this is in quadrant 1, everything is positive in quadrant 1. So like your cosine value and your sine value, remember cosine is like your x and sine is like your y. So everything is positive, remember, in quadrant 1, right? Cosine and sine are both positive. So by default, this is going to be positive 4 over 5. However, had this been another quadrant, like let's say this had been in quadrant 2, in quadrant 2, cosine would have been negative, but sine would have been positive. Think about that. Cosine's like your x. X's are negative in the second quadrant. So had this said we were in quadrant 2, I would have chosen the negative 4 over 5. It's one or the other depending on which quadrant you're in. So keep that in mind. We'll see that again. Okay, number 7, it says using periodic properties, find the value of each of these special trig angles. So it says they want sine of 9 pi over 4. So what I want you to notice when they're asking you to figure these out, and these are those special trig angles, 9 pi over 4, that goes with what's called a reference angle, and we'll get more into that in the next section, but that goes with what's called a reference angle of pi over 4. So the value for this is going to be the same as the value for the sine function at the regular pi over 4 location. The difference is the quadrant that we might be in. Let's do this. Before we get too into this, let's talk a little bit more about these quadrants that I just mentioned. So in this graph up here, let's just remind ourselves what we mean when we're talking about positives and negatives in each of these quadrants, because that's going to get more important as we go along. So remember, use this graph right here for just a second. Remember that you can think of cosine as your x and sine as your y. So if you kind of think of them as like an ordered pair, cosine is x, sine is y. In the first quadrant, both are positive. Cosine is positive, sine is positive, because x would be positive and sine would be, or y would be positive. In the second quadrant, cosine becomes negative, sine becomes negative, just like your x and your y would. X would be negative, but sine would stay positive. In the third quadrant, what happens? X is negative and sine is negative. So both your sine and your cosine are going to be negative. Then when you get to the fourth quadrant, your x's go back to positive. So that means your cosine is positive, but your sine, which is really like your y, stays negative. So keep these in mind because this little diagram is going to be very, very important. So, all right, let's talk about this 9 pi over 4 value. What we know is that this is going to have the same value as the sine of pi over 4. That's the idea. That's the logic. So go back to your table that we had earlier. Eventually, you're going to need to have these memorized, but for now, let's just use the table. So back up here at pi over 4, right here, pi over 4, our sine value was the square root of 2 over 2. So keep that in mind. Sine is the square root of 2 over 2 at the pi over 4 location. All right, so sine of pi over 4 is the square root of 2 over 2. So then the question becomes, is this positive or is it negative? And so that depends on which quadrant I would end up in if I'm at 9 pi over 4. If you remember in the previous lesson, we talked about coterminal angles. So 9 pi over 4 is coterminal with pi over 4, but what quadrant is it actually in? One way to figure this out is to change this to a mixed fraction. So if I say, what is 9 pi over 4 as a mixed fraction? You would say, okay, 4 goes into 9 twice with 1 left over. So that would mean it's 2 1/4 of a pi, 2 1/4 pi, basically. So 2 with 1 left over, right? So if we were to graph this on the circle, remember we'd start out at 0. Remember we rotate. From the previous lesson, we rotate counterclockwise as long as the angle is positive, which it is. It's 9 pi over 4. So this would be 1 pi and this would be 2 pi. Remember, 2 pi is a complete rotation. So then I want to go another 1/4 of a pi, which puts me right into the first quadrant. So that means I end up in the first quadrant. So in the first quadrant, what did you say about sine values? Sine is positive in the first quadrant. So this is going to be positive pi over, I'm sorry, not pi over 4, I'm getting the wrong thing. It's positive, what was the number we said from previously? Sorry, my eraser to work. There we go. the number we said earlier from the chart, remember, was, here it is, the number was the square root of 2 over 2. Oh, I think I actually wrote that down. Wait a second. Here it is, square root of 2 over 2. So we know it's going to be positive square root of 2 over 2. Obviously, we don't have to write the plus sign. I'm just trying to be emphatic. But because it's in the first quadrant, this angle ultimately is in the first quadrant, the value is going to be positive. It's the same quantity as the pi over 4, the original pi over 4, but it's positive because it's in the first quadrant. Let's try this one, 8 pi over 3. So first of all, that is coterminal with pi over 3. So the value is going to be the same as the tangent value at pi over 3. So if we go back to the chart, let's look up what tangent of pi over 3 was. Here's pi over 3. Our tangent value was right here, right? Square root of 3. So let's jot that down, that tangent is equal to the square root of 3. And then the question becomes, is this positive or negative? So to figure that out, I need to determine what quadrant 8 pi over 3 is. So let's change this to a mixed fraction again, the way we did here, because it's top heavy. Let's change it to a mixed fraction. So this would be 3 goes into 8 twice with 1 left over, right? 2 and 1/3. So that becomes 2 and a pi. So graphically, what would that look like? We would go around the circle once, that's 2 pi, but then we'd need to go another third of a pi, which puts me right back into the first quadrant. So this is in the first quadrant. So in the first quadrant, all right, let's talk about the sign of tangent in the first quadrant. Tangent, remember, is the ratio of sine over cosine. That's what we just said on the previous page. Right here, tangent is the ratio of sine divided by cosine. So think about that for a second. If sine and cosine are both positive, positive divided by positive is still a positive. So this is still going to be positive, but square root of 3 is going to be the value. Okay, let's try the next one, cosine of negative pi over 4. So the reference angle is pi over 4, so we know it's going to have the same value as the cosine of pi over 4. Let's go back and get that. Oh, what did I just do? I just zoomed out. That's okay. We can still use the chart. Pi over 4, the cosine value was square root of 2 over 2. So pi over 4 is where sine and cosine values are the same. They're both square root of 2 over 2. So cosine is pi over 4. I'm sorry, cosine of pi over 4 is square root of 2 over 2. So let's jot that down. And then we just need to figure out whether this is positive or negative. And we're going to determine that by the quadrant. So we know it's going to be square root of 2 over 2, but is this positive or negative? That's the question. All right, how do we figure out where negative 9 pi over 4 is? Well, a couple of things going on. First of all, this is an improper fraction. We need to make it a mixed fraction, just like we did earlier, but it's negative. So we're going to rotate in the clockwise direction. First of all, what did we say 9 pi over 4 was? As an improper fraction, it was 2 1/4 pi. But we want to go in the negative direction. So if I graph this, remember we rotate clockwise when the angle is negative. So one trip around the circle is 2 pi. We want to be another quarter of a pi. So that puts me right there into quadrant 4. So this is in quadrant 4. And what do we know about cosine values in quadrant 4? All right, so right here, quadrant 4, cosine is your x, so cosine is positive. So this is still positive. I was thinking we might get a negative one here, but there we go. So cosine is going to be positive because we end up in quadrant 4. All right, the last one, we've got secant of 13 pi over 6. Let's start with just pi over 6. So secant of pi over 6. So what you need to recognize is secant is the reciprocal of which function? We said earlier, secant was the reciprocal of, where is it? Right here. Secant is a reciprocal of cosine. So what I'm going to do is I'm going to take the cosine value at pi over 6 right here. Cosine value at pi over 6 is this number right here. So the cosine is root 3 over 2. Let's jot that down. All right. So the cosine value, cosine of pi over 6 is root 3 over 2. So because secant is the reciprocal of that, all I've got to do is take that fraction and flip it. So that means I've got 2 over the square root of 3. So we know the value is going to be 2 over the square root of 3. The question now, is this positive or negative? So let's change the 13 pi over 6 to an improper fraction again. So 6 goes into 13 twice with 1 pi left over. So this is 2 and a 6th pi. So if I go around the circle, 2 pi puts me right there. Another 1/6 of a pi puts me right into the first quadrant. So again, this is in the first quadrant. The secant value, the sign for it, will be the same as its reciprocal. Whatever the reciprocal is, the secant is going to do the same thing. So cosine, of course, would be positive in the first quadrant, so the secant will also be positive. So this is 2 over the square root of 3. Of course, that's positive. I'm not going to worry about rationalizing the denominator. We'll practice that in class, but this is all I'm interested in right now. Okay. I'm not going to do the unit circle right now. I want to do that with you guys as a group. So hang on to this and bring that to class tomorrow, and we will take a look at filling the whole circle in. All right.